Ready? Yeah. All right. We're going to get a demonstration of one of the two main algorithms that I saw going around the room here. This one looks pretty good, so let's see your technique here.
All right, so I approached the problem in the same way that he led over here, because I was good. So we have 473 and then 289. Okay? So we need to subtract that, and I think it helps to kind of visualize that grid paper. You know, it helps especially for middle school kids see that organization. So if you just go through and do, just like we did here on the subtraction, 4 minus 2, well, you do with 2, 7 minus 8, now we're into negatives. Middle schoolers hate negatives, but deal with it. 3 minus 9, you've got -6. You know, you can't, just like we can't leave an answer over here like this, we cannot leave this answer here. So
you can.
Well, yeah.
People just don't like
It's
it.
usually not.
The answer is 200, -10, -6, but
So if you think about it in the sense of I've got these pebbles, you know, I've got 2 pebbles in this slot, -1 here, -6 here, you need to do that borrowing. So if I take 1 pebble away here, it really is like adding 10 to the next. Okay? So that leaves me with 1. And then a -1 plus 10, there you go with adding your integers. So that's really good practice there. So then you've got a +9, and I still have the -6, so do the same process to the next group, all right? If I take 1 pebble from that group, that's really adding 10. So 1, there's my 8, and -6 plus 10. There,
Very good. Like that.
so it looks like just subtracting without worrying about place value. And by the way, this is setting you up for when it's 4x squared plus 7x plus 3 and 2x squared plus 8x plus 9. You just subtract. There's no borrowing or carrying in algebra in those situations. And then you do some, can we call it unexploding, to turn 1 pebble here into 10 there instead of the other way around? Fission and fusion for the 2 operations, sure. Absolutely. Okay, so that's certainly one of the main algorithms I saw. It goes through negative numbers, which is cool. But I think some other people did it a different way that didn't have any negative numbers in their process. Is that right? Do you want to show? Somebody from this group, do you want to show?
Go ahead. I did a smaller one. Go ahead. Yeah, he wrote it out right.
So we started with the same problem here, and I just kind of like borrowing, but in this case I wanted to start with my 473, and I knew that I wasn't going to be able to take 8 tens from 7 tens, so I did the 3, and I took one of the pebbles here and exploded it into this column, and I still had 3 left there. So I took 1 from here, exploded it into 10, and put it in this column. So then I moved over 1 more, I have 3, and I exploded one of the pebbles from here into this column. I still had mine.
13 plus 4.
Thank you. And then the subtraction from there, I could do 13. Go girl.
Right. Great. And I think if you're actually doing this with real base 10 blocks as your pebbles, this is definitely the natural way to do it, right? Trying to take 8 of those 10 strips away, I only have 7, I can't take 8 away, so I take one of my big 100 ones and I chop it up into pieces. So this is definitely the natural way to do it when you have the physical base 10 blocks as your tool. I'm going to talk about this one just a little bit more because I kind of think of it like this. I have 473. And I want to take away 289. Well, the way pebbles disappear is they explode, right? So I just explode. 200, 80, 10, 20, 30, 40, 50, 60, 70, 80. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I want to get rid of 289 pebbles, I just blow them up. 2 here, 8 here, 9 here. So this is pretty much like what you wrote here, just in pebble form. So this -1 and -6, what are they like? They're explosions without a dot. They're anti-dots. Yeah. So this is the representation of 200, -10 or -1D, -6. But that's not our customary way of writing numbers. If something explodes, we have to have something there to blow up. So that's when we go through the process of unexploding. You know, this dot turns into 10, but we have to fill in the hole. And then this dot explodes and turns into 10, but first I'm going to use my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.